You're going to find equation of a linear function. So when you speak of a linear function, you are basically referring to a straight line. So before we start the lesson, we need to introduce the standard form of a straight line. It is very crucial to first understand the standard form of a straight line before you approach the equation. In fact, before you get the equation of the linear system that is required basically. So suppose the standard form is written in a form of y equal to mx plus a c, or else it may be y minus y1 equal to m into x minus x1. So these ones, a c represent a constant. We call it a constant, or we call it the y-intercept of the straight line. It is a y-intercept of the straight line. So we are basically unpacking the formula for the straight line, which is the linear system. So this one, let us write it neatly here. So basically referring to this m, we are basically referring to m gradient, which is represented by y2 minus a y1 and the x2 minus the x1. So what are we actually referring to? We are basically referring to the gradient of 2 points that are in a straight line. Suppose we are having a straight line. First of all, if the straight line is like bending on your right hand side, it represents the positive gradient. So we're basically saying the gradient of the straight line is positive. Basically it is positive. Then if it's a vice versa, if it bends on the left hand side, so suppose the gradient of the straight line is negative. So we're having a negative gradient of skis. We're having a negative gradient of the straight line. So this is the gradient. Suppose we are having y2, y1. So basically maybe we are given a point which is on the straight line mx plus c. We're having maybe 1, 0 is to 1. First 0 is represented by x1. First y is represented by y1. Suppose the point number p is 2 is to 3. Then we are having x2. So this number denotes x2. This one denotes y2. So basically y2 refer to this number and x2 refer to this variable. Then 0, 1 refers to these variables which involves ones in the formula. So how can we get now the equation of this straight line? Suppose we are given the straight line. How can we now find the equation of the straight line? It's quite easy. We are going to use both formulas. First formula, y equal to mx plus a c. We are first going to calculate the m gradient because we are not given the gradient of this line. So how can we find the gradient? Easy. We use this one. So it's m what? MAP. We're calculating for gradient AP. So basically it's gonna be YP, because a YP represents the X, the Y2 basically, minus a YA, which represents X1. It denotes X1 basically. So let us move to this one. It's a XP minus XA. So we are going to substitute now. Let us substitute. A YP is this one. A YA is this one. So it says YP and the Y2. I made a mistake, it is a 3. A y2 is denoted by a 3. A y1 is denoted by a 1. So this is the minus for the formula. This is a 1. You can be given like negative numbers. It depends. 3 minus a 1. So x2, it's a 2. It's a 0. So at the end of the day, you are going to have a 2 out of a 1. So the gradient for this line is going to be a 2. So how can you now find the equation? In the equation, we're having now this m. You see, we're having this m. We're having this m. What is left? It is the constants. So how can we now find the constants? Easy. C y is equal to mx plus c. So you use between these 2 points, you choose. Me, I am choosing this point B. I am going to use this point B, which is represented by 2:3, the point which is on a straight line. So basically, let us now use this point. We are having a x, we are having a y. Let us now direct substitute. It is a 3. The gradient is going to be a 2. Then this one is going to be a x. It's going to be a 2. It's going to be a 2. It is very difficult to work alone because working alone needs multitasking. So let us proceed. We are having a c, which is a constant. We are looking for this c. 2 times a 2 is going to be a 4. 3. Let us make this one to be the just substitute formula. Then we can say this one and this one is going to be 3 minus 4 is going to be c. Therefore, c is going to be a -1. Therefore, the final equation is going to be y equal to gradient. We are no longer having m. Instead, we are having a 2, which is denoted by a 2. 2x comes back minus 1, which is constant. So how can you now prove this equation is correct? It's easy. You can easily say 2 x is a 2. You see, how can you now find this y constant? You see, how can you now find this y constant if you want to? Basically, we want to find this. If we substitute x, we want to find a 2 here. Okay, how can you find a 2? Easy. Take the value of x here. We can find the value of y. Take the value of x, a 2. If we can substitute, we can easily say y is equal to 2 into the value of x is a 2. We want this y. Minus 1 is going to be minus 4 minus 1. So we're having this 3. This 3 is this 3. How can you find the x? You can easily take a y, then substitute to the equation, then get a x. You are basically verifying whether the equation you got is correct or incorrect by using a back substitution. So here it's easy. This one, I recommend this one basically, because this one, it's easy. You easily say you are taking this coordinate. You easily like simplify this thing. You say you calculate, as you calculated on this one, you calculate the gradient. After calculating the gradient, then you take the point. You choose between these ones. This one represents the x1. If you choose p, 2 is going to be the x1, 3 is going to be the y1. If you choose a, x1 is going to be this one, y1 is going to be this one. You see, it's easy. You just say gradient times this one, gradient times this one, then you substitute. It's just a matter of substitution, because after finding the gradient of a 2, you easily say 2 times x minus y1. Your y1 was, if you say it's a, you are going to choose this one. If you said you choose this b, you are going to say it's this one. Bye bye.